NENOMATICA, where mathematics meets YouTube excellence. Welcome to our math tutorial on monomial divisibility. Today, we'll explore when one monomial is divisible by another, a fundamental concept in algebra that will help you with polynomial factorization and simplification. Let's start by understanding what monomial divisibility means. A monomial A is divisible by a monomial B if the result of dividing a by B is also a monomial. This is possible under specific conditions, which we'll explore in detail. Now, let's examine the first condition for monomial divisibility. Condition 1. All variables present in monomial B must also be present in monomial A. For example, if B contains the variables x and y, then A must also contain these same variables for A to be divisible by B. For instance, if B is x squared y cubed, then A could be x to the fourth power times y to the fifth power, because A contains all variables that are in B. Let's move on to the second condition for monomial divisibility. Condition 2. The exponents of each variable in B must be less than or equal to the corresponding exponents in A. Let's see an example. If B is x squared y cubed, and A is x cubed y squared, is it divisible by B? Let's analyze. For x, the exponent in B is 2, and in A it's 3, so this is fine. For y, the exponent in B is 3, but in A it's only 2, which is less than 3. Since the exponent of y in A is less than the exponent of y in B, the second condition is not satisfied. Therefore, A is not divisible by B. Now, let's work through a complete example where A is divisible by B. Example, let's take A as 12x cubed y to the fourth power z squared, and B as 3xy squared. Let's check both conditions. Condition 1. B contains variables x, y, and A contains x, y, z. Since C is not in B, this condition is satisfied. Condition 2. Let's check the exponents. For x, the exponent in B is 1, and in A it's 3, so 1 is less than 3. For y, the exponent in B is 2, and in A it's 4, so 2 is less than 4. Both conditions are satisfied, so A is divisible by B. Let's calculate the division. A divided by B equals 12x cubed y to the fourth power z squared divided by 3xy squared equals 12 thirds times x cubed slash x times y to the fourth slash y squared times z squared equals 4 times x squared times y squared times z squared equals 4x squared y squared z squared. So A divided by B equals 4x squared y squared z squared, which is a monomial, confirming that A is divisible by B. Now, let's look at an example where A is not divisible by B. Example, let A be 10x squared y cubed, and B be 5xy to the fourth power. Let's check both conditions. Condition 1, B contains variables x, y, and A also contains x, y, so this condition is satisfied. Condition 2, let's check the exponents. For x, the exponent in B is 1, and in A it's 2, so 1 is less than 2. For y, the exponent in B is 4, but in A it's only 3, so 4 is greater than 3. The second condition is not satisfied, so A is not divisible by B. If we attempted the division, we'd get 10x squared y cubed divided by 5xy to the fourth power equals 10 fifths times x squared slash x times y cubed slash y to the fourth equals 2 times x times y to the power of 3 to 4 equals 2x times y to the power of negative 1 equals 2x over y. Since the result has a negative exponent, it's not a monomial but a rational expression, confirming that A is not divisible by B. Let's summarize what we've learned about monomial divisibility. A monomial A is divisible by a monomial B if, and only if, 1. All variables in B are present in A. 2. The exponents of each variable in B are less than or equal to the corresponding exponents in A. When both conditions are met, the result of dividing A by B will be a monomial. Quick challenge. Is 15x cubed y squared z divisible by 3xy squared? Think about it for a moment before we check the conditions together. The variables in the divisor are x and y, which are present in the dividend. So the first condition is satisfied. For the exponents, x has exponent 1 in the divisor and 3 in the dividend, so 1 less than or equal to 3. Y has exponent 2 in both the divisor and the dividend, so 2 less than or equal to 2. Both conditions are satisfied. So 15x cubed y squared z is divisible by 3xy squared, and the result is 5x squared z. Understanding monomial divisibility is essential for algebraic operations like factoring and simplifying polynomial expressions. Remember the two key conditions. 1. All variables in the divisor must be present in the dividend. 2. The exponents in the divisor must not exceed the corresponding exponents in the dividend. These rules will help you determine whether one monomial is divisible by another and calculate the result when division is possible. Thank you for watching this tutorial on monomial divisibility. Practice these concepts with various examples to strengthen your understanding of algebraic operations. Welcome to this mathematics tutorial. Today, we're going to learn about monomial divisibility. Understanding when one monomial is divisible by another is an important concept in algebra that will help you simplify expressions and solve equations more efficiently. Let's start by understanding what it means for one monomial to be divisible by another. A monomial A is divisible by another monomial B if when we divide it by B, the result is also a monomial with integer coefficients and non-negative exponents. Let's look at an example to understand this concept better. Let's consider this example. We have a monomial, A equals 6a cubed b squared c to the fourth power. And we want to determine which of the following monomials A is divisible by. First, let's check b equals 2a squared bc squared. To determine if A is divisible by B, we need to check if the division results in a monomial with integer coefficients and non-negative exponents. Let's compute a divided by B. We have A over B equals 6a cubed b squared c to the fourth power divided by 2a squared bc squared. Now, let's simplify this expression. For the coefficients, we have 6 divided by 2, which equals 3. For the variable A, we have a cube divided by a squared, which gives us a to the power of 3 minus 2, which equals a to the first power. For the variable b, we have b squared divided by b to the first power, which gives us b to the power of 2 minus 1, which equals b to the first power. For the variable c, we have c to the fourth power divided by c squared, which gives us c to the power of 4 minus 2, which equals c squared. So, a divided by b equals 3abc squared, which is a monomial with an integer coefficient and non-negative exponents. Therefore, a is divisible by b. Now, let's check another example. Let's check if a is divisible by d, where d equals 3a cubed b cubed. Again, we'll compute a divided by d. Let's simplify this expression. For the coefficients, we have 6 divided by 3, which equals 2. For the variable a, we have a cubed divided by a cubed, which gives us a to the power of 3 minus 3, which equals a to the power of 0, or simply 1. For the variable b, we have b squared divided by b cubed, which gives us b to the power of 2 minus 3, which equals b to the power of negative 1. For the variable c, we have c to the fourth power divided by c to the power of 0, since c doesn't appear in d, which gives us c to the fourth power. So, a divided by d equals 2 times b to the power of negative 1 times c to the fourth power, which simplifies to 2c to the fourth power divided by b. Since we have a negative exponent in our result, a is not divisible by d. Let's summarize what we've learned about monomial divisibility. A monomial a is divisible by another monomial b if when we divide it by b, the result is a monomial with, first, an integer coefficient, not a fraction, and second, all exponents are non-negative. In our examples, we found that 6a cubed b squared c to the fourth power is divisible by 2a squared bc squared because the result is 3abc squared, which has an integer coefficient, and all exponents are positive. However, 6a cubed b squared c to the fourth power is not divisible by 3a cubed b cubed because the result includes b to the power of negative 1, which violates our second condition. Remember, when checking for monomial divisibility, always verify that the result of the division gives you a monomial with an integer coefficient and all non-negative exponents. Before we conclude, let's look at one more example to reinforce our understanding. Consider monomial a equals 6a cubed b squared c to the fourth power, and monomial c equals 5a cubed c squared. Is it divisible by c? Try to solve this on your own before we go through the solution. Let's work through the solution together. We need to divide it by c and check if the result satisfies our conditions. A divided by c equals 6a cubed b squared c to the fourth power divided by 5a cubed c squared. For the coefficients, we have 6 divided by 5, which equals 6/5. For the variable a, we have a cubed divided by a cubed, which gives us a to the power of 0 or 1. For the variable b, we have b squared divided by b to the power of 0, since b doesn't appear in c, which gives us b squared. For the variable c, we have c to the fourth power divided by c squared, which gives us c squared. So, a divided by c equals 6/5 times b squared times c squared. Since the coefficient is 6/5, which is not an integer, a is not divisible by c. Here are some tips to help you determine monomial divisibility quickly. First, check if the coefficient of the first monomial is divisible by the coefficient of the second monomial. Second, verify that the exponent of each variable in the first monomial is greater than or equal to the corresponding exponent in the second monomial. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.